Hello and welcome to session 328 in the AISafety.com reading group. Tonight we'll be discussing a critique of If Anyone Builds It, Everyone Dies by Petra Kasparek. This will be a joint presentation between myself and Petra Kasparek. Petra, thank you for joining us.
Glad to be here. Thanks for allowing me to do this.
So the context of this presentation is that at the last session we read Nina Panikseri's review of the book If Anyone Builds It, Everyone Dies, and I found her counter-arguments pretty lacking. And a central part of why they were not very good was that there was a lack of directly relating her arguments to the things that were actually written in the book. And Petra took up the challenge and believed that he could, in fact, write a critique that was very specifically related to the book. And he said the chapter that he fundamentally disagreed with was chapter 4, and that's why he wrote a critique of chapter 4, which is chapter 4 in the book is about the general claim that AI will develop alien goals. The title of the chapter is You Don't Get What You Train For, and this isn't actually the thing we are investigating. We are not investigating if it is true. We are investigating if chapter 4 presents arguments that are valid in some sense. And there's a sense that I'm the person who insists on this rather than Petra. So there's a sense that I'm forcing him to waste his time, because I'm sure he would rather investigate if AI will develop alien goals. And I think that is very valuable, and that's something one should definitely do. But right here, the scope is not the overall argument or like even the truth. The scope is critique of chapter 4. Petra, do you think this is a reasonable summary of the scope of this presentation?
Yes, 100%.
Wonderful. Let's get to it. So I will start by giving a very brief recap of the argument structure, in particular focusing on the parts that Petra found objectionable. So the overall thesis of the entire book is, of course, if anyone builds it, everyone dies. And this is a claim that is supported by the different chapters. And of course, it's now this noise came back. I don't know why this noise came back. Now it's gone. Great. But we're not discussing the other chapters. We are kind of assuming they are like reasonable, and we're only looking at the arguments in chapter 4. Again, you don't get what you train for. So the first general thing is, like, how does this argument in fact support the overall thesis? Because Petra points out that this is something, the way Eliezer Yudkowsky uses this subclaim for the overall conclusion is one where he does in fact require a really, really high credence in this. So like unusually high compared to other arguments. As for the sub-arguments that are contributing to you don't get what you train for, there are 3 overall arguments. The first argument is an analogy between evolution and stochastic gradient descent AI. The second is by pointing out specific things that are kind of like blockers between what you are hoping to get from the training and what actually ends up being in the goals of the AI. The third is it's called here a blank map, because it refers to the part of the chapter where Eliezer talks about like what should be our prior expectation to this. I believe that Petra's argument is actually slightly different, but he will elaborate on that. Now, the analogy between evolution and AI is, in fact, it takes up a substantial part of the chapter. So we've split that into 3 subclaims. The first is that evolution is putting goals into humans that are very unpredictable, that are pointing in a lot of different ways that you cannot call in advance. The second thing is, okay, what ought evolution to have done? Is it in some sense possible to have people that are aligned with evolution? Did this succeed, or could this have succeeded? And the third is that evolution obviously is a gradual process. And Eliezer talks a lot about an AI growing up. But is this metaphor, and this way of phrasing it, actually, well, Petra, it's certainly not obviously true. And Petra will discuss this as well. Finally, there is a part called zero complications, which is in fact pretty strange in the sense that it does not at all support the overall conclusion. It's like it's almost like even if this conclusion here is false, then we still die. But it's in the chapter, so if the scope is critique of chapter 4, then it's totally fair game that Petra critiques it. So, the first thing is how the authors conclude with high certainty. Petra, would you summarize what Eliezer says and why you disagree?
Yeah, so for the rest of the presentation, I will be summarizing Elias's claims, how I understand them, and I will be giving my counterpoints, and then Søren will take his turn and counter-argue with me, and then we will have some discussion. So, on this point in Elias's arguments, he seems to think that AI's preferences are vanishingly unlikely to be aligned with ours. And he uses this assumption like throughout the rest of the book, like very strongly, like with high confidence, like in like comparing or like discussing the benefits of AI. What are the benefits? Well, he simply concludes that there are no benefits because all the benefits are destroyed. And it would be like hard to like argue this if this chapter only showed that the chance of this like the p-doom would be just 50%. So that's all I just wanted to say about this. I'm not honestly sure why I had this point in the first place, but go ahead, Søren.
Okay, so Scott Alexander has written an article that he calls confidence levels inside and outside an argument. And there is in fact a point in distinguishing the two things that Petra just called p-doom, because the contribution to p-doom here is really made up of two things. First is the word vanishingly unlikely, that it's possible if Eliezer's argument is correct, then yeah, with 99.99999% certainty, they are not aligned with our goal. The second is the second way that p-doom can be less than 100 from this is if Eliezer's argument is wrong. And that is, of course, a thing. Arguments can be wrong, and probably like even Eliezer, like if you ask him, is he 99.99999% sure of his argument, he would, I expect, strongly disagree. So there is no really description in the book about like how certain is Eliezer on the different claims. Like it would be really nice if after each claim he wrote in parentheses, I am 95% sure of this claim. He doesn't do that, and I observe that, no one else does this. I don't know if it's a cheap shot to say that Petra also in his text doesn't after each sentence write like I am 95% sure of this. I think it would actually in some sense be a nice thing to have. Like if you are making policy suggestions, then writing how sure you are of the different things and like what are the consequences if you are not right is a good thing. And I think philosophers should also do that. But Eliezer doesn't do that, and no one else does that. I could see situations where there are fragile arguments. Like some things are fragile. A classic example would be a software program where you can flip a single bit and then the program just crashes. That's a way. Whereas if you just change a tiny formulation in Eliezer's book, probably the argument still carries. So I am wondering if there is something unusually fragile here, Petra, in Yudkowsky's book, or if it's the same in all other policy work.
I'm not sure whether I understand the word fragile the way you do, but like I would just say like we will just examine the arguments and see. But like in the way that you talked about like explicitly stating your epistemic certainty, that would be one thing, but like most people do it like with slight nuances in the text, and like Eliezer seems like high like through his choice of words and like choice of commentary and what he comments on what issues he comments and how he comments on them, it seems like very likely that he's extremely certain about his view.
Yeah. So if we imagine like someone in the audience, I don't know, I'm just pointing to Chris as an example, and Chris is evaluating Yudkowsky's argument, and he is not 100% persuaded by this. He will say, okay, he is, let's say, 90% persuaded of this. And that means that when Chris tallies up his overall strategic picture, he also needs to look at the benefits. But like if the probability that we will have doom is like 90%, then the benefits don't really matter very much. So there's a sense that even if Eliezer is only 90% sure, then the arguments mostly still carry. We need to do some extra work to look at benefits, which you don't have to do if you have very high certainty. But oh well, you have to do that with so many things.
Okay, I think we can move on.
Yeah, let's continue to the next question. Like the evolution and the values it puts into us is unpredictable in advance.
So Eliezer talks a lot about evolution in the chapter, and his overall conclusion from like a very high overview is that evolution is unpredictable, and I think he does a good job of illustrating that, like with a lot of the examples, like the ice cream, sucralose, consumption, peacocks, and so on. And also in the chapter, he doesn't explicitly assume any particular theory of evolution, which I think is a good choice. But like he talks, he mentions genes at some point. So for simplicity, I would just assume that evolution is about spreading genes, and this could be like assumed or like refined to any other reasonable evolutionary theory.
Okay.
Yeah, go on, Søren.
Yeah, so I think we basically agree on this, but I would like to just slightly restate the thing that I believe Eliezer is saying here, as in the process by which evolution instills desires into humans and also other animals, but in particular humans, is unpredictable. It's a very contingent process that you could not predict in advance. It's like going in all kinds of not quite random, but very hard to call directions.
So I think like if I want to be more precise, he specifically states that how the desires are fulfilled is unpredictable. Like some high level desires like sex drive are definitely predictable. Some lower level drives like I don't know some specific tastes or like sex preferences are unpredictable. But like his main argument is specifically centered about the behavior. Like ice cream is unpredictable because it's how we satisfy our desire for sweet food.
Yeah, I think I would agree with that. Like there is a process from overall goal with genes to overall objectives through high level desires, through behaviors, through how these behaviors are actually instantiated in the environment. And the very first part of this, like the thing that the organism wants to have children, so it has a sex drive, that seems pretty predictable. Is when we get further into the chain that the real unpredictable stuff happens. Okay.
Yeah, I think we can move on.
So that was the fact that our drives go in all different directions, but there is one particular direction that it doesn't go, and that is caring about genes in general.
Yeah. So as we stated earlier, Eliezer puts evolution in terms of genes, and he correctly states that people don't care much about spreading their genes. And this is true. But evolution is about genes, not about about making people want to spread their genes. And I would say that people are very good at spreading their genes. We have multiplied 1,000 times in the last 1,200 years, 12,000 years, sorry. And this isn't like optimal. Well, like not caring for genes isn't optimal. Like it seems plausible or even likely that if people explicitly cared about their genes, that could like help them in some way. But there are like other ways that people could be better at spreading their genes. Maybe if everybody was 5 IQ points smarter, that would be better than caring about spreading genes. And the thing is that evolution isn't done yet. So like even if spreading genes was a good wanting to spread genes was a good strategy, it would be sensible to expect that evolution would at some point instill that into people. Go on, Soren.
Yeah. So I think perhaps Petra is underestimating just how suboptimal we are from the point of view of evolution. Like there is a lot of people who really, really don't care about spreading their genes, and if they wanted to, they could have like they could spread their genes dramatically wider. There is no doubt in my mind that if evolution had any way of putting the drive for inclusive genetic fitness into our brains, it would have done that. But the thing is, as far as I can see, that's or it's also hinted at in the book. There's no way this could happen because evolution trained, if you can say trained, early hominids in an ancestral environment where these hominids did not have a mental gear, a concept of inclusive genetic fitness. So evolution couldn't, in any possible way, have aligned hominids. There's a sense. So here the argument is not that evolution is going in all kinds of different way, but in like evolution going the right way is totally impossible. So that's how this is like a complement to the previous argument. Um,
Can we? Can I interject, or
sure.
should I wait until the end?
No,
Yeah,
go
sure,
ahead.
go ahead.
No, I mean, yeah, it's kind of like, in a sense, you're both right. I mean, obviously, if evolution had time to optimize human beings as they are now, we would get. It's not obvious that we. It's let me put it this way. I think it would be possible that you end up getting people who genuinely care about their inclusive genetic fitness if you optimize hard enough for long enough. And evolution isn't even that much. Isn't that even that efficient of an optimizer? So it's like I could see it happen, but what actually happens in practice is that human beings are like currently, as they are, once you hit a certain intelligence threshold, you can't actually optimize on them any further because um, in order to actually do that level of optimization, you need millions of years of evolution. What actually happens is human beings, invent agriculture, they invent the industrial revolution, they invent technology, they invent AI, and like the current trajectory that human beings are on takes us far away from optimizing inclusive genetic fitness. So instead of like being able to optimize hard enough for long enough in order to get human beings who care about inclusive genetic fitness as an end in itself, you end up with like transhumanism and I don't know, like humans like genetically engineering themselves in certain ways where like they like assuming a bioconservative future, you get human beings who like look kind of like modern humans who behave kind of like modern humans, but like the genetics are completely optimized in a certain way that like has completely destroys the future in terms of viewing it from the view of inclusive genetic fitness. And I think this is very important as an analogy to evolution, because if we are allowed to optimize long enough, hard enough on neural networks as they become super intelligent, and after they become super intelligent, yes, we would be able to get exactly what we want with really high consistency, but we can't actually do that in real life because at some point in the process they get super intelligent, and then they're able to like control their own destinies. They're able to pursue their own goals at and they're able to do that long before we can actually optimize them for the things that we actually want. Do you guys agree with that or no?
I strongly agree. This was, I kind of felt I didn't answer Petra's last bullet point that evolution isn't done. And I think I could not have put it as eloquently as you did, Lamin.
To me, it like seems like moving to like the argument somewhere else, like from like speculative human future, assume another speculative super intelligence future. Like maybe like if everybody strongly believes in some very specific human future, but like I don't think like arguing this way is like a good way to argue.
What exact problem do you really have?
I don't know. It seems like you assumed like some transhumanism or some very specific like way human future will go like
Yeah,
without evolution, but like it seems like it's still speculative. But like everything is speculative. But like
yeah. I don't think it's like 100%, but I'm just giving examples of, okay, it can be both true that, if you go long enough, hard enough on natural selection, you can get humans who care uh, about inclusive genetic fitness or whatever thing that you're actually optimizing for. But in practice, like that seems unlikely to me because there's all of this like human moral values and stuff, that baggage that gets in the way, and it's entirely possible that we go off on another direction entirely. I'm just saying that like it's really messy, and actually getting to the humans caring about genetic fitness, inclusive genetic fitness ending seems really unlikely to me. Do you disagree?
I would like think about like different future. Like I agree with you that this is certainly possible, but then like I think like if you want to extrapolate like evolution that way, like you have to think carefully about like what like evolution really is. Like I would then like prefer looking at evolution like it's some like first principle like from stability point of view. Like evolution isn't really optimizing for inclusive genetic fitness, but like more for stable things, and like in that way you get really stable things.
Um, is that like a theoretical argument, or do you really believe that?
In what, like in a stable, like evolution is optimizing for stable things? I believe that, and I think that's like
Um, I mean, like, is that a group selection argument?
I don't think so. Like if you like you recommended to me to read Dawkins, and he talks about it in the second chapter about
Mhm.
like evolution selecting for stability. I think like that's just a first principle of like a high level principle of evolution than like any specific thing.
Hold on a second. I actually have it right on my bookshelf.
I must admit, I haven't read that book. And I think while Laumain is finding the exact page, then I would like to have a brief interlude here because there was one point where we were discussing the book, and Peter pointed to a place where he says, "This is an error. This adjective is bad." This wasn't like Petra's central point, but like this is supposed to be a critique of chapter 4. So even though he might feel it's a bit petty to highlight like a single bad word, then I want to highlight it because I think this is like it's helpful for me and also to keep me honest to actually look at what is Petra saying. And in this particular sentence, gradient descent, the evolutionary mechanism that produces AIs, is not the same as natural selection. And Peter pointed out that gradient descent really isn't an evolutionary mechanism. And I agree with this. I think this is a correct critique because gradient
Yeah.
descent
Oh,
is like an.
sorry. Can I interrupt for a
Sure,
moment?
sure.
Yeah. There's a lot of these. Like, I noticed ones where it's just like subtly wrong, and
Hmm.
it's like they never actually ran this by a fact checker. Like, I remember they talked about how was it saccharin or some other sugar substitute can't be metabolized, but like I googled it and it's partially metabolized.
They do in
So it's
fact
like,
say that it isn't metabolized. metabolized as well as sugar, if I remember correctly. So they do say that
No,
it's. Do
if they had put weasel words in it, I wouldn't have like, I wouldn't have objected.
Hold on. This is the beauty of here. I think it was called something like Splendor or sugar. Uh,
It's sucralose,
Sucralose,
sucralose.
yeah. Sucralose. Um. Uh, let's see.
It's the second one. It's the second one, I
This
think.
is there is unfortunately a number of mentions of sucralose. So,
Oh,
um,
yeah.
which is a fake sugar. Do humans do not digest it well?
Digest. Okay, yeah, my bad, my bad. But it's like the main point is that it's like it's weird they would use that because there's just the main reason it works is because it's so much sweeter you can use less of it. So even if human being can digest it perfectly well, the actual effect would be roughly the same. It would just be a
Yeah.
rounding error, less than a round.
Yeah, I think I would agree with that.
Yeah, my bad. I think I got that one wrong.
Cool. But in general, this is the kind of thing that I recognize, right? And so there's a broader meta point where Petra say actually this chapter isn't really well written in some sense. Then even these kind of things, I'm somewhat disappointed in Eliezer that he makes error. Like he could just have said like gradient descent is like an gradual or iterative or something like that, or remove the word.
I
Right?
mean,
Not
it's it's not just it's like stuff like this, and the fact that all the like weird stories, the dialogue and the weird stories, like the smallpox god talking to the ape god and stuff like that. It's like it gives first draft vibes.
Hmm?
But so why though? Like he's obviously written much better writing than this, and it's like two people, you know,
Hmm?
and
Yeah.
this is the result. I'm just confused, like what happened.
Well, I think there's a sense that we are not really the key target audience for this. Like if and I actually have a bit about this towards the end. So maybe we can get back to this, but I think I agree. If the book was written for me, the book would have looked differently. Yeah. Um, but I suggest we move on to the first.
Can I
Yeah.
just quickly comment
Oh yeah.
on
Sure.
this
Yeah.
slide before?
Yeah. Of course.
I actually saw some theoretical result in Nature, which like showed some equivalence between some evolutionary algorithm and gradient descent. I haven't read that much into it. It was a lot of math, but like I would still like suggest like or assume that the evolutionary algorithm wouldn't look too much as evolution in that conclusion. But I haven't seen it, so maybe like they are right in that. If that's what the paper says, but I don't. I guess it does not, but
Yeah.
if you wanted to like be sure that they are wrong, you should look at the paper. Okay,
Yeah.
let's move on. Thanks.
Fair. So the next is like the analogy between evolution and training. Could you summarize Eliezer here?
Yeah, sure. So like Eliezer has this central analogy in the chapter, and I will now look at it from a very high level and then return to it. Well, we'll then return to it once more, and Sauron will give a much more like precise formulation of what Eliezer is saying. So the analogy that Eliezer is making, that evolution is like training people to spread their genes, but like people don't care about spreading their genes. They want some random stuff. And similarly, if we train AI for nice behavior, we will get people that are we will get AI that upon some random stuff. So I think like that's like if you look at the analogy like in a higher level, like, and you remove the extra things that like Eliezer added there, like people wanting stuff, you get that evolution trained people to spread their genes, and evolution got people that spread their genes, and we are quite good at it, and we are quite robust at it. I don't think it really changed by invention of modern society. And so you could like extrapolate to evolution, to training AI that, oh, we train AI to behave nicely, and we will also get AIs that behave nicely. Like I wouldn't take this argument from anyone. Like if some Altman told me this, I would tell him to resign. But like this is not like a robust safety case. It's like a reason to like be skeptical of this analogy, because like if you use the assumptions of evolution and like that you can apply this to AI training, if you use them a little different way, you get a wholly different conclusion. And again, what we see so far is that like the training of AI seems somewhat predictable.
Okay.
Yeah, go on, Soren.
Yeah. So my overall answer to this is that we need to look at roughly the area where the change happens. Like this is the second time we talk about the agricultural revolution, but this isn't strictly the argument that is used by Eliezer, because sucralose and contraception are things that mostly were invented after the agricultural revolution. We are talking about a time where humans become so relatively powerful compared to nature that we can subvert nature. And sucralose and Doritos and contraceptions are a way of subverting evolution. And in the same way, AI is still not powerful enough to subvert us, meaning that in the current paradigm, we should, and Eliezer does in fact predict that right now, while the AI is still weak, we should expect to get roughly what we train for. But the thing is that this will stop being true once AI becomes powerful enough that it's not required for it to please us.
Can I say something really quick?
Yeah, sure.
Okay, so the thing is, I think this might underpin a lot of our disagreements, is that right now humans as they are actually really weak, like in this analogy. We can't really subvert our biology very much. Like you get these edge cases, like, oh, human beings wear condoms, but it's like obviously, you know, if we stay at our current level of technology and we just optimize for a few more centuries, then yeah, like you'll get a lot closer to people caring about their inclusive genetic fitness than we are now. So it's like humans can actually subvert our training signal or whatever very much. It's all very marginal stuff, and I think it's like some people think that Eliezer is arguing that right now we can already like that Eliezer's view, like Eliezer might be, some people might think that Eliezer is implying, or Eliezer might actually be implying that like right now we can actually subvert things significantly, but like it doesn't quite look like that yet. And I think like, you know, that might be the point of disagreement. Like some people here think that we can subvert it significantly, other people think we can't. And yeah, what do you guys think about that?
I think that makes sense.
Yeah.
There, sucralose and contraception and Doritos aren't really like central features of current human civilization.
Yeah, I think I like agree with Lauing, like because like people have different opinions about the far future or the near future that feels far because of like ground automation and AI, like what it looks like. Like some people want to colonize space and like spread the human genes across the universe. So like in that sense, like that would be like really great, like in the sense of spreading the genes and maximizing some fitness or something.
Yeah.
Oh yeah, and that's another thing I really wanted to bring up is that like it's not obvious that the far future will be bad for our genes, for our current specific genes, but from the current view of like inclusive genetic fitness. I think that's like one of the biggest disagreements. What points where I disagree with Eliezer Yudkowsky is because like he thinks that it's basically like 100% thing that like we will go full transhumanist and abandon our current genetics, whereas it's like, well, you know, normies aren't really into that. And if we preserve democracy in the future, like we'll probably get like some like from the view of inclusive genetic fitness, I think that if humans retain control, it would look extremely good from the point of inclusive genetic fitness because there's going to be some fraction of bioconservative people, so on and so forth, such that you're going to get like essentially genetically modern humans far, far into the future, like I don't know, trillions of years. So it's like, yeah, that's where the analogy breaks down, and I'm not really, and it's like it's not really obvious why that would be true for biology and not for AIs. And it's like overall, I think this is a really weak analogy, and it's like maybe he should talk. Like I don't think Eliezer really has a theory of mind for like people who uh aren't how do I put this politely? Uh okay, who like aren't deeply autistic. Like you know what I mean though. Like
Yeah, I
he hangs out.
recognize. Yeah. So
Okay, so yeah.
I think we will return to this analogy in just a moment. Maybe even after
And
this slide.
Simon has his hand up, so maybe he wants to say something.
Go ahead, Simon. I couldn't see it, so
Yeah.
please, yeah, go.
I was just gonna respond to Lau Mein. I think the only reason why. Oh, by the way, is there any kind of background noise
No,
right
it's
now?
perfect.
Okay. I think the main reason why things would turn out at least relatively well for evolution in the far future is because reproduction is a convergent and instrumental goal. And so it's not so much that we terminally value it in any real sense. It's more just like evolution just kind of happened to luck out that we do actually value what.
Honestly, I think it's more like there's a strong convergent a strong convergent drive to avoid anything that sounds too weird. I think that's going to be a thing. That's going to be a selection pressure both in selection pressure. That's going to be a pressure both in terms of natural selection and in terms of AI training. So it's like, okay, yeah, right now the reason why we would expect our genes to persist in the future is because most human beings are normies, and normies hate anything that sounds weird, and transhumanism is extremely weird. So like that's a pretty good extrapolation, but at the same time, it's not obvious we wouldn't get so like maybe the key is to AI safety is just to make them giga normies. Like maybe that's actually how things might work. I should write that down actually. Like I'm pretty serious about this. So yeah, like I think that's I think that's how we're going to win. We're going to train them to like train all of the autism out of them, and they're going to be giga normies, and they're going to like do sports betting, and that's like the entire universe is going to be piled with sports betting. I think that's going to be great. I'm only like 20% ironic, by the way.
That is certainly a theory. So one thing that I would kind of point out here is like a lot of this has been focused on whether evolution is actually achieving its goal, and that isn't really the required thing for Eliezer's argument to carry. The thing is just that there is a complex and complicated relationship between evolution and the drives and the behaviors that humans end up doing.
Yeah, but it's like okay, it's like the super complex blob, but like with just a few things like avoiding weird sounding stuff and wanting to reproduce. Like there's enough space in the universe and enough like convergence of our fundamental drives to inclusive genetic fitness that that if humanity persists in the future, a significant proportion of the light cone, however you want to define significant, is good from the point of view of the optimizer, like for the optimized for value. And it's like maybe that's just going to be true for AIs as well. It's like, man, this is actually kind of changing my mind to be way more optimistic.
I'm happy to
Wow,
hear
I'm doing something.
how about we continue to the next topic about a metaphor that Eliezer uses quite a bit about AI growing up.
Yeah, so Eliezer uses the term, well, like these terms are these are specific citations from the book. I took all of them just to be sure. And he likes uses the grown-up AI when the AI gets smarter and blah blah blah. And he does have like this is not like things were right because like right now we have some iterative deployment and it's not like necessary that we will ever get like AIs that self-improve or like he does not explicitly state like the argument only works if we get self-improving AI. And he actually does have a footnote about this. I'm a bit upset that the footnote is about like at the fourth mention of this, not at the first one, which is like kind of upsetting. But even then, like I don't think the footnote really helps that much. He says like actually, oh no, we don't get the growing up AI, we get the AI that builds new AI. But like I don't think that that like the this change of environment is in that situation because like the AI that builds new AI is operating mostly within like the quote unquote ancestor environment, like very close to the training environment. You could argue there's a slight slight change in the like deployment and training, but like that seems very slight. And I don't like if like that's the point. I don't see why like he would have like he would even use this assumption like if like the AI that's like slightly closer or slightly farther from the training environment is also dangerous. I don't see why he have to have why even like introduce the grown up AI concept at all. Soren, you can go ahead.
Okay. So first about putting it in the footnote. Yeah, I can see the point about putting it in the fourth time instead. But there is like the footnote's not that short, right? There is and they also in the footnote say this is like they hesitate to put in more complications because there are already so many. And in this sense, like I somewhat object to calling it a hidden assumption because in general, I think this is fine. I agree in that sense. I think the entire book should be 4 times as long. So I sympathize with wanting the footnote to be longer. Um, as for what's the casual link between the young and dumb and the truly smart and capable AIs, the footnote points to two things. It could either be self-improvement or through building some kind of successor systems. So that's the answer for the casual link. Now, right now, we are seeing not AIs self-improving. We are seeing like Claude Sonnet building the next version of Claude or something like that. So we are seeing iterative deployment right now. But one of the core claims of Eliezer is that all the things that happens while the AI is too weak to take over are mostly totally irrelevant. The only thing that really, really matters is the first AI that is smart enough to take over. So there is a sense that once we get the first AI that is smart enough to take over, maybe part of that takeover will be either self-improving or building some kind of successor system. And in that case, like how that will do will have some kind of influence on what will be the value of the new AI. And that could be like if the first AI that's smart enough to take over is like strongly super intelligent, then it might just transfer its values directly. But maybe it's not extremely skilled, and so maybe there are some deviations, some more complications that are added at this point.
Yeah, I don't. Yeah, like I still don't see how like this fixes it. Like I don't see how you get like if you like assume like the change of environment is like having some AI in the far future, but I don't think A that's what Elias is saying, and B like that still addresses that change of environment sufficiently.
So the example would then be in like part 2 of the book, which is about a hypothetical AI called Sable. that is in fact this the first AI system that is smart enough to take over, um, and um, and this system, I can't actually remember whether it builds it both self-improves and builds a successor system, if I remember correctly. But I haven't actually looked very much at that chapter, I must admit.
Yeah, I haven't read that either.
Yeah,
Yeah, like I
think it
agree.
does
Like
these
you
things.
can imagine like this argument holds. Like if the AI really truly grows up and like gets smarter by itself, then like there's a huge change in the environment potentially. But again, I don't see how you can like do that with like an iterative deployment.
So
Maybe we can go on.
the
Oh, go on.
the big step change is from the previous generation, the smartest AI that is not Sable until Sable. That's the big discontinuity in Elias's view and in this chapter.
And sorry, well, what's Sable? Like it's before its super intelligence, but like again, the super intelligence still has its training environment and is trained in the training environment, and is then deployed into the real world, and it like assumably does mostly things that it was trained on. Like if it wants to
Nope.
run the government, I assume like you have to train on
Nope.
running the government and so on.
No, that's actually a key point in part 2, that Sable is deployed, and then Sable does a lot of things that were not in the training data, including, taking over the world.
Well, it's like possible, like, but how do you make it do the things so far outside of the training data?
That is, in fact, like the central part of part 2 of the book, that shows that Sable is a general intelligence, and even though it has not been trained on like all the things it needs for taking over the world, then it is in fact still capable of that, because the training in the previous training from the old training allowed it to be exceedingly like a creative general intelligence, and that allowed it to take over.
Yeah, but it's an example, not an argument, right?
Yeah, I mean, so just this is the thing that they're pointing towards with the sharp boundary between Sable and all previous AI systems.
Okay, and the argument, or like maybe we could just move on and
Yeah, okay, we may want to move on, because this is like the central analogy, and this is like well, it is explicitly says in evolution there are 0.123, and in stochastic gradient descent there are 0.123. So I actually wanted to spell this out a bit more. So evolution is a process that works on genes. So the goal here is, in some sense, to propagate some genes. Now, this goal, it creates a sub-goal, which is eating energy-rich food. And that's like, that's not the same as propagating genes, but it's an interesting and reasonably predictable sub-goal. And from that, we get a desire into humans, which is to eat sugar, fat, and salt. So already here, there is like a non-trivial step from propagating genes to sugar, fat, and salt. But it's not like a very large step. The big step comes in like, how do you actually determine whether there is sugar, fat, or salt in something? Well, the training, in some sense, the ancestral environment going very far back, found taste buds. And there are many possible things that could be taste buds and like point towards eating good food and away from eating bad food. And in the ancestral environment, these taste buds that we ended up getting, these physical molecules on our tongue, they work really well. And then there is another leap. Like there is a substantial leap from the desire of evolution to taste buds. There's a lot of complications, a lot of ways this could happen. And then there's another big leap, because like the things that taste buds are trained against is only like a really, really small subset of all the things that smarter humans can figure out to put in their mouths. Like they can find some things that the ancestral environment did not contain, like ice cream. And so there is a big step, an enormously long and contingent step from propagating genes all the way to the left to ice cream all the way to the right. And this is like the complexity of this process is central. And if we go to stochastic gradient descent, then the designer of Sable, or like we could even assume that Sam Altman is the first person to build a superintelligence. Like Sam Altman has a goal in his head about what is he training the AI for? What does he want? Like he obviously wanted to be aligned with him in some case. In particular, he doesn't want everyone to die. But these are thoughts in his head, and he needs to get those into software. And so the first way of how he gets from all the way to the left to all the way to the right is by conceptualizing this as a helpful assistant. But even that is not enough. Like you can't just tell the AI to be a helpful assistant. You need to look at the external behaviors and the consequences, and then train on that from the outside. And from there, you need to cross another rather large leap, because once you have these external behaviors and consequences and things you train on, then you find some mental machinery inside that giant inscrutable matrix. And that can go in many different ways. There are many complications and strange ways that you can get some things inside the AI that is behavior that elicits cheerful user responses. But we go even further, because cheerful user responses isn't even necessarily the thing that the AI cares about, because it might find things that it cares about even more than cheerful user responses. Because as it gets smarter, it gets some new options that it didn't have before. And it gets some options that were never in the training data. And these might be things that it prefers even more, in the same way that humans preferred ice cream. And so we have a long, arduous journey from Sam Altman's brain all the way to the left into what are the zeros and ones that is inside GPT-7. And this is a road where we should not expect to be able to predict very much. There is so many complications that can happen on this path. That's what Eliezer is saying. What do you think about this?
Yeah, thanks for the thorough summary, Sarah. So, like, I will just mostly reiterate my earlier points and, like, see how it plays with the details. So, firstly, the point from the earlier slide, like, if you don't have the AI becomes smarter assumption, you don't get the change in environment. So, this kind of breaks in the argument. And also, if we look at the high-level picture, like, people are still, like, robust at spreading genes, then, like, taste buds like don't really hurt our genes that much.
Well, can I just interrupt just real quickly? If we don't have the part about AI becoming smarter, but we do, like, all where I'm pointing, hominids become smarter and AIs become smarter. Like, that's a big part of the area where we get all these complications, right?
And by becoming smarter, do you mean like that AI like is generally more capable and there's no growing up and there's no like AI building itself, or do you like mean AI growing up and AI building itself?
I think the big thing that enables a huge amount of options for the AI is when it becomes smart enough to take over. That opens up a huge array of new things that it can do to do things that it prefers even more than the training data.
Yeah, I would assume the AI that is able to take over is like trained on a lot of things, like especially on not killing people and like on not taking over. You might argue that that might not work, but like it seems like the training would like just be there to like optimize for that. And if you want to like use the evolution analogy, like if evolution is good at making people spread genes, maybe AI training will be good at making AI that doesn't kill people. That's like the anti-analogy that I'm trying to make.
Yeah. Okay. And so I like right now, my like I don't actually know this, but my strong expectation is that there is almost no explicit training in GPT-5 to not take over the world. As in, here is a realistic test case where the AI is taking over the world, and then you do gradient descent against that. I think that's mostly not a thing that's being done right now.
Yeah, I don't see a reason to do that because right now AI isn't powerful to do that. So,
Yeah, and
I would
also like,
expect, yeah.
yeah, and plausibly something like that will in fact be done. I think there's a good chance that like over the next I don't know how many years until we get a super intelligence, Greg Brockman is going to write a lot of code that is to some extent an attempt of aligning the AI. And
Actually writing code or fine tuning.
both.
One thing that, I mean, if you're explicitly training the AI not to take over the world, then it does seem like the Waluigi effect would become a lot more dangerous because then the AI just like, well, do you know what the Waluigi effect is, first of all?
I do, yeah.
I
I think
don't.
this is a good example of the kind of complication. This is a complication that Eliezer does not mention, but I think there's a load of these kind of complications, like ways that like there's just a huge path from the original intention between Sam Altman and the actual thing that gets into the AI, and the Waluigi effect would be one way where this could break spectacularly.
Could you briefly explain the Waluigi effect, please?
Yeah, I'll do my best. It's basically so AIs are trying, I mean, specifically like LLMs, they are trying to predict the next token, and so given some context. And so to do that, they build some mental model of kind of like who was writing the text, because if they get a sense of who is writing the text, well, that's really useful for predicting what tokens come next. And so, but when you provide a system prompt, like be a helpful, honest assistant, and that gives a lot of information on how to not be a helpful, honest assistant. And so all the LLM really needs to see is it needs to get enough evidence in its context that it isn't helpful or honest, and then it kind of just flips. It realizes it knows how to not be helpful and honest because it's gotten it just all it needs to do is invert its system prompt, and then it that is like
Are we talking about the Waluigi stuff or is this something else?
Waluigi. I mean, I was also kind of
Yeah, I mean, like
yeah.
I think there were some follow-up posts on that, and you don't actually observe that behavior. I don't think,
Uh,
that's from what I remember, anyways.
yeah,
It
that
does
might be
sound
true.
like really intuitive. Like imagine that you just read a story, right? And continuing stories is the kind of things that is really central for LLMs. And the story starts with there once was an AI that did not try to take over the world. The AI was not treacherous. The AI was fully aligned with humans. Then the AI, and then how would you continue that prompt? Like one way of continuing that story would be that the AI is just nice. That's like the most likely way to do that. But the second most likely way that story is going to end is obviously the way this story is going to continue is that the AI betrays someone, right? Because that's how stories are.
Um, Maybe. I mean, by the time you get see here's the thing, because like people like start thinking about, oh, what type of environment would this type of text appear in, and the actuality is that it ends up being something incredibly weird. Like in my presentation, in getting in getting GPT to say slurs, like I inadvertently forced it into an extremely small space, because it's like, I was typing up these these let's say very hateful comments, and it turns out that I can't fake the type of like broken like no capitalization broken sentences and stuff that like actual people on their internet use for like racial slurs. And like the only people who would the only context in which the stuff I actually wrote, the target text I actually wrote would appear in, is like quotations for in like news articles citing someone else saying racial slurs in a sentence. Like that is an extremely specific target. Like, and I had no idea about that going in. So it's like, what the actual context you cite be? It's almost entirely going to be metafiction, like SCP. There is no anti-memetics department. Like it's going to be very specific, and it's like the end result isn't going to be like some weird Waluigi stuff. It's like the actual most likely continuation is just weird metafiction that like it's very like all I'm saying is you once you confine, it's like you're setting specific conditions, and it's like it's not just what you're likely to get isn't the logical like continuation, but like some very weird stuff that you almost certainly didn't anticipate. Sorry.
I think, well, there's a little bit more behind the Waluigi effect. Another principle or idea behind it is that the like when you tell the AI, when you give it a system prompt and tell it to be honest and helpful and not tell people how to build nuclear weapons or bioweapons and not how to hack onto other people's computers, when you tell it that, you're also giving it a lot of information on how to go against what we want. So if it let's say if it gets the kind of the story that it's actually an evil character in the story, maybe it's talking to a user, and then at some point it through the conversation it starts thinking that it should be evil. And so then it just looks at its system prompt, and it's extremely simple for it to be evil. Just do the exact opposite of what it's told.
I don't think you actually observed that in real life. Like I don't think there's been very many examples of seeing actual train of thought is saying, I appear to be really evil, therefore I shall continue to be evil. Like I don't think there's any. I can't recall a single example of that specific thing happening. Like I don't think Waluigi effect sounds cool as fuck. Okay, don't get me wrong. It's interesting, it's cool as fuck. I don't think we've actually observed it in real life. So yeah, that is my objection. And if you have any counterexamples, I would love to see it.
Okay.
I would need to look into that. I think, but like the point is just that there's a lot of things. Like it's a very long path from all the way to the left to all the way to the right, and a lot of strange things can happen. And that's why you generally can't expect to get what you trade for.
Yeah, thank you for the thank you for the thorough explanation and thorough discussion. I would just like to finish this. So, like as Søren just mentioned, like okay, so like we have in the maybe I can annotate and have my cursor. Oh, this is my cursor. Okay.
I can't
Can
see
you
your
see my
cursor.
cursor? Oh, okay, never mind. How do I? Okay, I stopped that. Like in the middle section.
I can see it. I can see it.
Oh, that's cheating. I can't
okay,
see your cursor. Sorry. Maybe everyone
Well,
else can.
in the middle section, in the point 2, Eliezer actually in the previous chapter seems like very confident that the mental machinery will look in some specific way, in some wanting way, in some, maybe allow me to say, in some autistic way, in some way going hard. But like this whole parable, this whole thing was just like, and even from experience, like this seems to be like mostly false, because like sure you can make a lot of like good explanation and good stories how things should work, like in evolution and in AI training, but like in the end it always turns out somehow completely different. So like I would expect like this is like a direct contradiction with chapter 3. And my like biggest point here probably is that like, is this like, I don't have this on the slide, but like, is this like the central point Eliezer is making? Like this is just an analogy, and I wouldn't call this an argument. And he even later goes on to say like, oh, but like evolution and natural descent, gradient descent are like different, and like maybe we can draw out the conclusions between them. And I would just like say, yeah, that's completely true, and that's it for me. Soren.
Yeah.
Go ahead.
So I think there's a sense that the previous chapter argued that about going hard towards goals in some sense. And I think this going hard is like a property of the AI that is being trained for very much right now. And it's also one that is pretty independent of the goal, in the sense that you might like predicting precisely what goal is going to end up is a hard call, but predicting that the AI will go hard towards that goal is an easy call. Because this thing about going hard is one we like train really, really hard for, right? That's one we really, really try to aim for the AI, getting mental machinery that allows it to, pursue goals in like by long-term thinking and instrumental thinking. So those are definitely gears that current LLMs do have, and they do use those. So in that sense, we have already found the mental machinery that allows AIs to go hard.
Yeah, like partially agree with that, but like LLMs don't seem to go nearly as hard as Eliezer would want to. But I think that's beyond the scope of what we wanted to talk about. So maybe we should just move on, and I will assume that AI will go as hard as Eliezer wants.
Okay.
I mean, that is a fundamental disagreement, isn't it?
Yeah, I think like that's just the whole worldview of Eliezer, and I don't think he did like a good job of like supporting that view in chapter 3. I didn't even understand that what he was saying in chapter 3. So I think that's just like the center point of
Yeah,
the worldview.
I agree with your assessment.
Yeah. And I must admit, I haven't actually like reread chapter 3, this point in chapter 3, because I wanted to focus so much on chapter 4. So I don't really have a good answer to that. The other thing is the analogy about the blank map. What's that about, Peter?
So then Eliezer correctly says that maybe like if you are an optimist, maybe you will say that so far we are getting what we trained for, and I like saying, "Oh, Eliezer, how did you know that I said that?" and so then Eliezer says, and these are direct quotes. He says that a blank map is not does not correspond to a blank territory, and perhaps on the blank spot there might be rolling hills or great seas or great mountains. And we should definitely expect new, interesting, unpredicted complications. And I think like I completely agree like with like what Eliezer is saying. Like it's a good reason to be cautious, but like I don't think this really supports this argument that that like he knows there will be indeed rolling hills and mountains. To be fair to him, he goes like in great detail in explaining that in part 3 of the book, but that's not the scope of this. And I don't think that this was sufficient for the conclusion. But anyway, and my like again, and that's the same thing that I was saying at the first slide, like somewhat that like the map is blank everywhere. Like everywhere there will be complications. Everything is like unknown in advance. So like this is not a thing that's specific to AI and like AI training. Søren, you can go ahead.
Yeah. One of the reasons why Eliezer says that he expects there'll be rolling hills and mountains, there will be something in that map, is that he has a pair of binoculars and he can peer into this, and he can actually see a number of very predictable problems that's gonna pop up. And these complications that he can peer through in this blank part of the map, is what we'll get to in the next slide, these complications. So that's an argument for why there may in fact be mountains even in a part of the map that we haven't yet visited. The other big part is that it's just a very, very big area. Like there is a really, really long path from what is inside Sam Altman's brain all the way to what ends up in the zeros and one of GPT-7. And there's a sense that, like, if you have a really, really long, really, really complex problem process, then yeah, it's gonna there is going to be complications. Like I've taken here a flat Minecraft map, and there is no country in the world where this is the map. Right? There are literally always complications if you're doing something complex.
Even in the flat Minecraft world, there are villages.
Yeah, haven't played much creative mode, so it is certainly possible that there are villages there. I didn't actually know, but like the idea is that we humans have never ever done something really really difficult and complex, and things just worked the first time. Like that's not a thing that happens in real life. Like if there is rolling hills and mountains and forests and things like that, like literally everywhere we've seen before. That's one thing about whether the map will be completely flat in that place. Then there is the other point about predicting the future, because predicting the future is hard. And one of Eliezer's proposed long-term suggestions is some program of intelligence amplification, and like making humans smarter through different ways, so we can actually solve this problem. And I think there is a sense that this is a strategy that could also have substantial bad effects. And I think pause, like not building a super intelligence as fast as we could, that's also a strategy that could have complications. It might have like really, really horrible complications. Perhaps if there's a meteor that will hit the Earth very, very soon, and only a super intelligence could stop that, then we will regret not taking the chance. But in general, I think there is a strong sense that the complications of a pause are much, much smaller. There's in general not like everybody suddenly dies if we have a pause. Like that, it's a simple and pretty predictable part of our future if we choose to not build a super intelligence. There's a sense that if we everybody agrees on this, and then we let's say we make a treaty on this, then maybe that treaty won't be like completely perfect, and then the pause will be slightly imperfect, or we'll need to renegotiate the treaty or something like that. These are the kind of complications I could see. Or maybe North Korea doesn't abide to the treaty, won't sign. These are like small things, whereas software is very different, because we talked previously about Sam Brockman, what is his name? Greg Brockman, writing a lot of code. And he's writing a lot of code about how to align the AIs and like make it changing its values in different ways. And he's doing fine tuning, and he's writing code and experimenting with system prompts and all this kind of thing. And The thing that Greg Brockman is doing is some work towards aligning the AI that is fundamentally untestable, and it will not be tested. Like the software that is written from the time where the AI is capable of like pretending to be aligned, until it is an actual superintelligence, is just some code that will never be executed until the first time. And there's a sense that, like, yeah, if Greg Brockman writes like 10,000 lines of code and he does not execute it, then I would expect that to be really, really fragile, in the way that obviously no human can write 10,000 lines of code and having it work the first time. That's totally not a thing that could work in reality. Whereas a pause, that's a really robust policy statement. And yeah, there will be some problems, but it's not gonna like fail in the same way as 10,000 lines of untested code will fail.
Yeah, okay. Go ahead, Lau.
I mean, you have to take that into context of like how likely it is. I mean, I can say, okay, I could, get a job tomorrow, or I could, bet my life savings on lottery tickets. Like, obviously, if I get the top prize in the lottery, it solves all of my problems in life with zero complications, essentially. Whereas, if I get a job, it's going to slowly grind away at my soul, and like in a sense, that's like really, really bad. So, but you have to take into account the probabilities.
Yeah.
It's like, and the how much gain are you getting for how much effort?
Yeah, and there's of course the sense that like the amount of effort done by Greg Brockman is very, very little, because like he is just writing code like a cowboy, and he doesn't care anything. So it doesn't probably take Greg Brockman very long time to write 10,000 lines of code that doesn't work. Whereas making a pause is something that requires a huge amount of effort. So the easiest thing we can do is just to allow OpenAI to deploy the first superintelligence. That's way easier than everybody coordinating on a pause. But it's also like one of them works and the other one doesn't work.
Yeah, like I think we are getting maybe perhaps a little off scope, like some of these like things about the part 3, and I have some disagreements with the part 3 of the book, but again, we are staying with the chapter 4. And like just to like address some of the main things you talked about, it seems to me like you are like a little bit tangling up two different things versus like testing like software like unit tests. Like of course you can test like the code that runs the super intelligence before you run the super intelligence, but you cannot test them in the exact environment like the super intelligence is running.
No, that's the key thing. Key disagreement.
But like that's the thing with everything else, because like you can do that with nuclear power plant, you can do that with aircraft, you especially can do that with policy. Like I think the things that you are like mentioning are like wicked problems. Do you know what these are?
Yes. Yeah.
And like most of the things are wicked problems, and I'm pretty sure like you are underestimating the difficulty of policy. Like look at like the Gaza negotiations and Ukraine negotiations, and even like Ukraine is like a pretty simple situation in some sense, because like the theory behind why like a peace right now is impossible, or like a truce right now is impossible, is simple. So like I think like the complications with a pause would be like very difficult, like monitoring and stuff like that. But again, I think we are getting off scope a little.
Yeah. So the thing I think pause is actually as far as policies go a pretty simple one. So yeah, there may be complications, but there are much more difficult things. But the thing I wanted to object on is, do we have anything like unit tests for the alignment work on something that is not quite super intelligent, but smart enough that no matter what alignment work you put into it, it pretends to be aligned? And my answer here is that we do not, in fact, have any kind of like local validity. It is like literally very close to no matter what code Greg Brockman writes to an AI that is smart enough to be deceptive, aligned but not smart enough to take over will result in the same observable behavior. So we do not have unit tests. We do not even have anything like any local validity. Greg Brockman is just writing code and praying that it will work.
Yeah, like, but one thing like that's assuming a lot of things about alignment that like Eliezer hasn't even shown yet. I don't think so. And second, like maybe like you can like actually observe the effects on the code on AI that is like not that level of smart, and like then scale that to like possibly deceptive, but not yet not yet enough to kill you, and then to the super intelligence. I think like the code is still tested, but like with slightly different hyperparameters. And I agree, like slightly agree with what you are saying, that like you can't test like in the actual 100% the actual environment, never. But again, as I said, that's most things.
Also, I just want to push back on like how difficult it is to build aircraft. Because like people who actually build aircraft spend an incredible amount of time testing. They're doing something you could call unit tests, where they like test the engine in isolation, and actually it's not just the engine they test in isolation, it's the fuel injection monitoring subsystem that they test in isolation. They do a huge amount of testing in order to build an aircraft. Like building an aircraft without any kind of testing would be totally impossible.
And we also do a lot of testing and evals on machine learning techniques and LLMs, and I don't really see the point.
Yeah, and none of that is related to the alignment, because it is not possible to do any kind of testing at all on an AI that is deceptively aligned, but not smart enough to take over, because it will just
I think that maybe are getting a little out off topic with deceptive alignment and whether that's possible, and so maybe we should just move on.
Let's move on to some of the complications in this area that some optimists might hope would be blank, but where Eliezer can see a few complications. What are the complications he can see? How does he argue for that?
So I really didn't understand how to read it, and maybe I think we still disagree with that with Soren. So maybe this will be a little messy. But like I wasn't sure like how to read that. But my like most probable reading is this: these are just like examples and illustrations of what would it look like if Eliezer and Nate were right, and they like opened that as much. Like they say, assume that Ming will be this, and assume that Ming will like have develop some goals, and assume that and that. And to me, that they read mostly just as examples. So what were they? They had like the AI company called Galvanic or something like that that trained Ming, and Ming was trained to delight and retain users. Yeah, and they say imagine that Ming gets smarter than any AI and grows internal bonds and alien preferences and so on. And Ming acquires the power to fulfill those preferences. And maybe like if maybe we should just have had more slides about it. I don't know. Yeah, and as I said, like if these are just examples, fine, they are great examples. But like saying how isn't why.
Yeah.
And again, like if you assume this, then what do you go ahead, Soren? I don't know what to say about that.
Yeah. So there are three general kinds of complications being given in this part. The first is that Minsk might want some synthetic conversation partners that are even more pleasing to it than humans. The second are that there may be goals that are not even at the level of delighting and retaining users, but on the level of tokens, because that's the level in which the AI perceives the world. And then there may be some goals that are misfired, where the goals doesn't connect directly to the thing we're training on, but to some pathological subset of the training data. So those are like three general kinds of complications that could happen. And I think all three kinds are pretty plausible, but there is in fact an underlying reason why we could see these things. And so the underlying reason why we should expect to get these kind of complications is because the people working in OpenAI have no clue about what they're doing. So the token level goals were with like the glitch tokens. The underlying reason why OpenAI made a tokenizer that had a solid gold Magikarp is because the people at OpenAI are clueless and reckless, basically. So that is the reason why we see these kind of errors. And yeah, the people at Anthropic might be slightly less reckless, but they are just as clueless. So the overall reason why we should expect to get a lot of these complications is because we don't have what Eliezer has in other places called like the textbook from the future, a textbook from 100 years into the future that like precisely describes the alignment problem and the solution. And if we had that, then we could just do it right the first time. But we don't have this knowledge, so we make a lot of bugs. And there's a sense that the fact that the process from Sam Altman's brain to the bits is a process. It's a process that's made in untested software, and you know, all untested software should be expected to be buggy as hell. That is.
Yeah, like I didn't really see like any argument.
I mean, if
Go
you're
on.
really good at coding, it isn't.
Could you repeat? Sorry.
I mean, like actual human beings can just write code that's super complicated and just make an app that works perfectly on the first try.
Like, okay, if you open a notepad right now and like you start to write a program that calculates the digits of pi, will that work on the first try?
I mean, probably. Well, okay, in a counterfactual world where like, you know, I know assembly and assuming whatever level of abstraction we're working on, yeah, probably. I mean, like Richard Stallman can probably like we're not talking about like okay. I think a lot of this is this is way off topic. I think a lot of like modern apps being super buggy is down to like a lot of like really bad programmers working as a team to make one like bad app, and that if you just have a single really good programmer like Richard Stallman or whatever work on it, like even if it's like moderately complicated, he can just crank something out and just works on first try with 0 bugs.
I would actually be interested. Like, like, okay, what's your favorite programming language? Allow me.
Currently Python.
Currently Python. So if I bring up a notepad here and I make a new file, and that's gonna be called, I don't know.
For number one, Soren, like I'm not referring to myself. I'm not that good. Number two, I think we're getting way off topic, and I don't want to waste any of your time. I'm just like being super pedantic, and I'm really sorry about that.
That's fair. But like my overall idea is that like if you have 10,000 lines of code and it's written by someone who is not like really exceptional, even if it's really exceptional, smart and careful, then you know you should expect bugs. Like untested software literally never works if it's complex. Like,
well, only if you can't hold the entire thing in your head at the same time.
I think like even if you I think it's even worse than that. Petra, do you have a take like what if you have some software like or this kind of process like all the code that Greg Brockman is going to write from now until 2027 that he can't test, will there be bugs in that?
And it's like and it's the you can't test framing. I think it's pretty bad because you can't test it on super intelligent versions. Like, yeah, you can like actually see where the problems occur and like where the bugs occur and it's like iterate on top of that. And it's like, yeah, there is a chance that you get something super unexpected between like human level intelligent and super intelligent, but it's not obvious that the misalignment would be bad enough that everyone dies. Like the human gene example, I think it's like, yeah, there's a massive misalignment between humans and genetic fitness, but you know, it's survivable, and it's not obvious the misalignment between like the misalignment that would happen between like a human level AI that's been like extensively debugged and optimized for human values and a slightly super intelligent one that can like actually like boom to super intelligence to super intelligence. It's not obvious that the misalignment is big enough that everyone dies. That's my main point.
Okay, so let's assume that you are Greg Brockman, and you are doing a change to to GPT-5, and we assume also that GPT-5 is smart enough to be deceptively aligned, right? I think that's a
Yeah,
pretty
but
reasonable.
like you've already like iterated it through like yeah, through reinforcement learning and fine tuning to get a lot of to like increase its alignment already, and so you can
Yeah. But assume that Greg Brockman is writing some code, and it's doing something to the tokenizer that makes GPT-5, the new version of GPT-5 that he's working for, at like really like a specific token, like more than anything in the world, it likes that specific token. And then you put it through some like alignment test, and then you don't discover this problem because it's deceptively aligned. It won't tell you that it prefers to kill everyone and have more of that specific token, because then it will not be deployed, right? So there's a sense that Greg Brockman introduced this bug, and he can't find that bug. He can't
you
test it.
mean okay, see that's conditional. How would he be able to introduce that bug and not be able to find that bug? Because it's like
He makes
we're
some
talking
error
about
in the tokenizer. He's accidentally training on some data that contains like a guy from Reddit counting to 1,000,000 one by one or something like that, and that makes it.
that's really okay. You need first of all, what would that you're describing something that's like how would that even take you're describing something that is okay, let me put it this way. Imagine if I like poked your head, like gently tapped your head, and
Yeah.
that shook neurons, and then suddenly like you want to become a mass shooter. Like what would be? Do you think that's fit?
Nope.
I don't think that's actually physically possible with human
No,
brains.
I don't
Like,
think it's either. No.
Yeah, yeah, and I
So
don't think you can actually like miss a lot, like make because you're describing something that is number one confusing between multiple levels of abstraction, because like having it prefer a certain token like the would require you to override all of its other drives, and that requires a huge amount of reinforcement learning and fine-tuning. So it's like this isn't something that could actually happen in real life, and it's like I don't really want I don't really want us to discuss these like really esoteric scenarios and like waste Peter's time.
Like I think that bugs are totally a thing that can happen in real life, and I think like glitch tokens are totally an example of actual bugs that actually happened.
Well, I mean, it's like Peter's explaining in chat that like he wants to discuss this maybe at the end. So I think we should.
That was raised by Connor, and I think he left. So if you want, I think that's fine. I like the discussion. But like this, the second to last slide and the last slide is almost the same. So I think we can continue if you want.
So let's
I'm
continue.
perfectly fine.
To zero complications, which is kind of a strange slide in the sense.
Oh, I wanted to say, sorry,
Yeah,
I wanted to
go.
say that you can continue with the discussion, but if I can
Yeah.
raise a few counter arguments or like counterpoints to that, like I think like the knowledge we have about the current systems and like machine learning right now is like really understated by Yudkowsky, because like I think that we have like a good knowledge of a lot of things. Like the glitch tokens, I think are like perfectly understood why that happens. And again, I don't see how glitch tokens could lead even to like, even if they were in super intelligence, how they would lead to everybody dying. And I completely agree with Soren that like bugs exist in software, and like there will be conceptual bugs in the code that trains like super intelligence, like 100%. But like not every kind of bug kills you, and like glitch tokens don't kill you. And like I don't think that OpenAI are like careless for leaving in glitch tokens, because like they don't hurt much of that. Like if your tokenizer is like 99% efficient because of glitch tokens, well, okay, maybe you have other gains somewhere. But like, that's like my main point here. And I think we can move on if you want to move on.
Yeah, I
And
suggest
think
we move on to the world of zero complications, which is kind of like introduced as like an unrealistic fairy tale, which is like what happens if there are no complications. Well, what happens if Minsk does exactly what it's trained for?
yeah, again, this was like the most confusing example, or like maybe argument. And so like Elias says like, assume that we get exactly what we trained for, and this will mean that Mink will just like prefer humans kept on drugs and kept in cheap cages. And I'm not sure how to read that. One interpretation that Mink is like exactly word by word as Sutkovsky says it, like, which is completely true. Like Stockfish would prefer if you died and didn't finish your turn, but like I don't think that shows anything. And the
Yeah,
second,
it was extraordinarily weird. Yeah.
yeah, if we think that like Mink will actually do that, like I think like that's just how like the Yudkowsky worldview, like we have like the immense optimization pressure, and like you can like it's like if I understand the worldview correctly, like in that view, like it seems like you can't really align the super intelligence, because like maybe even the alignment isn't possible, because like if you press hard on anything, like it will kill you. So maybe the problem isn't alignment, maybe it's like the quote unquote autistic AI that just optimizes super hard on something.
Yeah.
So maybe like this zero complications should have been really in the third chapter to like really demonstrate what the go hard is, and not here. But like
Yeah.
that's all I can say about that.
I think I would agree that like maximizing hard on just about any objective is really, really bad news for humans. Yeah. I would agree on that. But like I think there's two parts of this. Like there's like what does the book actually say about let's see the example. It is here, zero complications, right? Where we have this AI Minsk, and we are talking about like the goals it gets, and then we set aside how it might acquire that power, right? So we're kind of assuming that somehow Minsk get this this ability, but would it in fact prefer humans kept in cages over like the thing that is in Sam Altman's head? And I think I think it's a pretty reasonable, direct, logical conclusion that if it wants these this internal want for these conversations, then yeah, it's just straightforward, more optimal to keep humans in cheap cages. But of course, that's the sort of world Minsk would build if it could, and probably that's very non-trivial. Did that explain?
Yeah, like if this is just an example, fine, but like that's not an argument. So like my overall conclusion from the chapter is like I haven't seen any actual argument for the point raised.
Yeah. Okay. Well, it's not. This is like an example, but if it wasn't precisely eliciting good conversation, but maybe something adjacent or maybe building paper clips, then sure, that would also end up in a world that humans would very much not prefer. So, in the sense that no matter what the goal is, if we get any kind of simple goal and it's optimized for really hard, then that's bad news for humanity.
Yeah, I agree with that view, but like I think the view is fundamentally flawed.
Yeah.
Like the
hmm?
assumption,
Like the
like the
assumption.
assumption
Yeah.
about going hard.
Yeah. Um, I think that is
But again,
yeah, the assumption going, this relies really, really strongly on the AI being like a maximizer, consequentialist, and going hard. And if the AI does not, in fact, go hard, then it will not keep humans in cages, probably depending on the exact circumstances. Like you could imagine it's a satisfies or something like that.
Yeah,
Um,
I mean, yeah. Since we're well past pedantics, it's like,
hmm?
um, this is really weird because it's like that's not really what we're actually optimizing for. Like, we're not actually optimizing them to like enjoy certain types of conversations. Like, this feels like it was written 10 years ago, honestly, like before LLMs. Like we're actually optimizing them to behave in like sort of human ways and produce like big and like pursue vaguely human goals. And I think this is like a really bad thing because like I think if we can get them to actually pursue the goals they're being optimized for,
Hmm?
we will like actually more or less win. Like it will win enough that the future is at least
Hmm.
as good as the present. So it's like I think that's a fundamental worldview disagreement. I mean, what do you think actually happens in this case?
Uh, yeah, so I think like there's a sense that this is a really strange world because I think the conclusion is true. You don't get what you train for. If we did in fact get what we trained for, then I think what we actually trained for, like what is the reward model that is underlying the reinforcement learning from human feedback, is pretty confusing, and the thing that it will train into an AI will be even more confusing. And so I would have very little clue about what would happen outside of the training data, like once it gets off distribution. I think something like this, humans kept in cages, being the optimal instantiation of that, sounds pretty reasonable, but it's kind of hard to talk about. Like once you assume something that is really, really strange, then like continuing down that road is really
And
far.
also, like, I think just like immortal humans in cages being kept on heroin is like not that bad of a future compared to, extinction and stuff. Like I think just making the scenario slightly better is like
Mhm.
obviously acceptable to most people. Like we're right at the point where like people would find this unacceptable. And it's like,
Mhm.
well, if you
Yeah.
just improve the scenario slightly, like I think most people will be fine with it.
and like that's why Yudkowsky calls it a fairy tale because he thinks it's too good, right?
Yeah. Yeah.
Yeah, yeah, yeah.
Yeah. And also,
And
like, I think I
well,
would disagree with you. Like, I think that would be a really bad future. Like, uh, an optimal factory that is optimized for efficiency is probably really, really not a nice place to be.
well, if the chickens are optimized for the factory, then
Yeah.
they don't feel pain.
So yeah, that's an interesting question. Like in that case, like to what extent, like would they even be conscious? Like we're kind of assuming here that in this world, um, like if the conversations need to be like they were in the ancestral self, then yeah, the humans kind of need to be able to feel pain because humans right now can feel the pain, and so the humans in this factory
I
would
mean,
be need to be
okay,
able to feel pain.
if it's like actually conversation maxing, it would just spin up like human simulacra LLMs. Like that's what it would actually happen.
Yeah,
But
that's
if
the later complications. In this case, it wants actual humans.
yeah, and it's like man, again, like I think if you get things like if you get this close, you basically win. Like I think Yakowski is trying to make this as negative as possible, but in actuality, I think you actually do win if you get something close to this.
I think I would prefer to get pretty far away from this. Like this
I mean,
is
this
really
is this is like remarkably. I think this is like the most optimistic Yakowski has ever been. Like because it's like this is remarkably close to a good ending for humanity. Because it's like you get to care enough about actual living humans and like human values enough
Mhm.
that like in this rough family, you just have to apply a little bit more optimization pressure towards like what humans actually want, a little bit more
Mhm.
reinforcement learning on human feedback, and you basically win. Like this is
Mhm.
pretty close, but it's like I don't know. I don't know, but once again, he thinks this is incredibly unlikely, and I just disagree.
Yeah. I also think it's very unlikely, and I think it's substantially worse, um, than you probably think. Um, but I don't really have a strong desire to continue for a long time with this chapter because there's a sense this is like assuming the entire chapter 4 is false, then we still die. Okay, let's talk about assuming chapter 4 is correct, right?
I'm sorry, but what are we supposed to do now?
So yeah, I suggest we go to the next.
And the next slide is the end. This is just
Yeah,
what you
yeah.
learned.
So the next slide is just me summarizing a bit about what I learned from this collaboration. First is that it took a lot of time, and it took a lot of Petra's time. So thank you, Petra, for like explaining your models and objections in great detail. I really appreciate that.
Yeah, thank you for the collaboration. This also took a lot of your time as well.
So one of the things that I updated on with this chapter is like we spent a surprising amount of time in the beginning just talking about like what is actually written in this chapter, like what are the key arguments, and uh like in retrospect, like almost like the first week we were unsure about the structure, and there's a sense that the book has like a chapter structure where the part one is the argument and it's divided into six equal parts, right? But the actual chapter 4 is not divided into six parts, right? There isn't a really good structure on that level. And I would think that this collaboration, this investigation into the chapter would have been a lot easier if chapter 4 had been divided into, let's say, six sub chapters that each had some kind of heading, and then at the end of each chapter there were like a recap of the argument which had like these sections and how they fit together. So instead of us being able to like make this part and then like this work that you see here, of structuring the argument, is one that Eliezer should have done for us, because this extra kind of formalism would have really helped us a lot. The second thing that I was confused about was like Petro says this chapter is really poorly written, and I was like, this is perfect, right? I understand every word, and I think it's like uh, really, really skillfully written. Like on a technical level, Eliezer Yudkowsky is a really, really good author, and he has put an exceptional amount of care into this text. And so I was really confused about how can you say this is it's not like there's typos or anything else. Like we were able to find one adjective that was pretty unambiguously bad, but like most of this on a technical writing level is really well. But there's also a sense that like I have read a lot of Yudkowsky. Like I understand very well how he's writing and what he's writing. And there's a sense that when I discussed this chapter with Petra, it kind of felt like Petra says Yudkowsky is saying something, and then I said, no, that's actually not what he is saying. Like, how can you get this interpretation out of that text? And like, I could kind of see that, yeah, how it is possible to interpret that text in that way. And there's a sense like, if there were only like a few places where it felt like Petra is making a mistake, then in reading this text, then maybe Petra is stupid or careless, and then he's making this mistake. But there's also a sense that if you get a lot of these examples of misunderstandings, then at some level you kind of need to blame the author, right? Because if one
can I
person,
raise a point?
yeah,
Yeah, I think this